Are you struggling to add a GPU operation in TensorFlow? You're not alone. Many developers face challenges when trying to implement custom operations, especially with GPU support. Today, we're going to walk through the process of adding a GPU operation in TensorFlow, and I promise you, by the end of this video, you'll have the knowledge to tackle this issue head-on. I completely understand how frustrating it can be when your code compiles but doesn't produce the expected results. It can feel like you're stuck in a loop of confusion. You're definitely not the only one facing this issue, and it's a common hurdle for many developers. Let's dive into the specific question at hand. One user reached out asking, "How do I add a GPU operation in TensorFlow?" They provided their code and mentioned that while they can compile and run their test script, the output is always 0. Sound familiar? If you're facing similar issues, stick around as we explore this together. So what could be going wrong here? The issue might stem from how the CUDA kernel is launched, or how the data is being passed between the host and device. Understanding the interaction between your TensorFlow code and CUDA is crucial for troubleshooting this problem effectively. And don't go anywhere. I have a crucial tip at the end that could save you a lot of time and frustration when working with TensorFlow and GPU operations. To address the issue with the GPU operation, the user should first ensure that the CUDA kernel is correctly configured. This involves checking the kernel launch parameters and ensuring that the input data is being passed correctly. Next, the user should verify that the input tensor is being populated correctly before it is sent to the GPU. This can be done by adding debug statements to print the input values right before the kernel launch. After confirming the input values, the user should check the CUDA kernel implementation. Ensure that the kernel is correctly accessing the input data and writing to the output data. The user can also try simplifying the kernel to isolate the issue. Finally, the user should ensure that the CUDA environment is set up correctly. This includes checking the CUDA version and ensuring that the GPU is properly recognized by TensorFlow. The user can run a simple TensorFlow GPU test to confirm this. Fun fact, did you know that the first GPU was released in 1999? It was called the GeForce 256, and it revolutionized the way we handle graphics and computations. Just imagine how far we've come since then. Now let's look at the answers provided by other users. An alternative solution provided by another user suggests simplifying the CMake configuration. They found that removing unnecessary options from the CUDA add library command resolved the compilation issue. Let's take a look at an answer from another user. This user suggests checking the official GPU ops building instructions on TensorFlow's website. They provide specific commands for compiling your CUDA kernel and shared library. They also note that if your CUDA libraries are not in the default location, you need to specify the path in the G++ command. Additionally, for some Linux setups, you may need to add a specific option to the nvcc command to avoid errors. Let's move forward and look at another answer. The user suggests a series of commands to compile the CUDA operation. They start by running CMake to configure the build, followed by the make command to compile the code. However, they encounter a warning about deprecated GPU architectures and an error indicating that TensorFlow is not recognized as a namespace. Here's the tip I promised. Always check your kernel launch parameters and data integrity. A small oversight can lead to big headaches, so take the time to debug thoroughly. And there you have it. With these troubleshooting steps, you should be able to resolve the issues with your GPU operation in TensorFlow. Remember, debugging is a part of the process, and with practice, you'll become more adept at it. If you found this video helpful, please subscribe for more tips and tricks.